Here we go, one more run through. This is number 17. Our job is to find the extreme values of f and where they occur. I'm going to try to do my perfect example. X to the 2/5 power has a domain of all real numbers, since we're allowed to square any number, and we're allowed to take the 5th root of any number. Unlike a square root, you could find a negative, or the 5th root of a negative number. For example, the 5th root of -1 is -1. If you don't know what the shape of x to the 2/5 power is, it looks about like this. It's a continuous function, and if we talked about differentiability, f is not differentiable at x equals 0. F has a cusp at x equals 0. Okay. However, f is continuous everywhere, and especially on our closed interval -3 to 1. So let's see. I'm going to write that. F is continuous on, and I'm going to use easier notation, -3 to 1. So f must have both a maximum and a minimum on that closed interval -3 to 1. Where might that maximum, where might that minimum occur? Well, if we use the graph, we would already know somewhere in here to find the endpoints of our interval. I bet f has a minimum at x equals 0 and has a maximum at x equals -3. But we're not proving that using calculus by using a graph, so we have more work to do. So let's see. A maximum can only occur at an endpoint or a critical value. We know what the endpoints, -3 and 1 are, so we need to see if f has any critical values. A critical value is where the first derivative of a function is equal to 0 or undefined. So x to the 2/5 power, we can take its derivative using the power rule, and we end up with f prime of x is 2/5, x to the -3/5. Let's rewrite that a little bit better notation. F of x is 2 over 5 times, let's see, the 5th root of x cubed. Okay, so f prime of x does not equal 0 anywhere. We want to look for where our first derivative f prime is equal to 0. You can see, maybe you can, I can, if I put a 0 in here for f prime, I'd have 0 equals 2 over all this junk. When I try to do algebra and multiply both sides of my equation by 5 times the 5th root of x cubed, I get 0 equals 2. So it must not be possible for f prime to be equal to 0. But f prime of x is undefined. Do you see it? At x equals 0. When x equals 0, we'd have 2 over 5 times 0. That's 2 over 0. We call that undefined. So we have 3 places where we need to test how large f is. Do you know what they are? A maximum can occur at an endpoint or a critical value. We have exactly one critical value. That's x equals 0. So we're going to do f of 0, which is 0 to the power 2/5, which is 0. I don't know if that's the largest or smallest yet. We need to compare. I'm going to do f of -3. Let's see, which is going to be -3 to the power 2/5. Okay, don't break out your calculators yet. Let's think about this. So -3 squared is 9. And let's leave that as the 5th root of 9. I can already tell that the 5th root of 9 is larger than 0. Okay, so I at least know f does not have a maximum at 0, and f does not have a minimum at -3. I still need to compare at what's going on at 1. Let's see, f of 1 is equal to 1 to the power 2/5, and that one I have. That's definitely 1. Super easy. Okay, so we can easily tell f has a minimum of 0 at x equals 0. But which is larger, the 5th root of 9 or 1? Well, the 5th root of 1 would be 1, and 9 is larger than 1. Let me see if I can explain that. Let's see. The 5th root of 1 is 1, and the 5th root of a larger number, 9, should be larger than that 1. So I'm confident saying f of -3 is larger than f of 1. Don't forget to write your answer. F has a maximum of the 5th root of 9 at x equals -3, and a minimum of 1 at, that's not true either, not a minimum of 1. A minimum of 0 at x equals 0. Ooh, we forgot something. What'd I forget? On our closed interval, -3, 1. That's my best answer. On the closed interval, -3 to 1, f has a maximum of the 5th root of 9, which occurs at x equals -3, and a minimum of 0 at x equals 0. Hope that helped.